Welcome Algebra 2, this is section 3-5, systems with 3 variables. The essential question is, how is solving systems with 3 variables different from systems of 2? So let's begin. So the big difference here is we now have 3 variables, x, y, and z, and we have 3 equations. So we need both. And what happens is this big mess of 3 equations solves down to an x and a y and a z, one value for each. So this equation solves to 3, 3, 1. So let's check this to verify that first. So if my solution is x is 3, y is 3, z is 1, let's check it. We have to check each of these 3 equations. They should all be valid. So this is going to be 2 times 3 minus y, so minus 3 plus z, 1 equals 4. And that's going to be 6 minus 3 plus 1 equals 4. 6 minus 3 is 3 plus 1 equals 4. And that means 4 equals 4, and that checks out. Let's try the next one. It's going to be 3 plus 3 times 3 minus 1 equals 11. So 3 plus 9 minus 1 equals 11. 3 plus 9 is 12 minus 1 equals 11. And 12 minus 1 is 11. And 11 does equal 11, so that checks out. The last one, it would be 4 times 3 plus 3 minus 1 equals 14. 4 times 3 is 12 plus 3 minus 1 equals 14. 12 plus 3 is 15 minus 1 equals 14. And 15 minus 1 is 14. And 14 equals 14, so all 3 check out. So we know that this solution is the solution. Well, how did I get that solution? And these kind of problems, there's basically 3 big steps here. So make sure you write these down very clear in your notes. These should be really big and easy to read. So step 1, step 2, and step 3. And basically with last week, you did step 2. Like this is solving systems of 2 equations. This is what we did last week, but now we add a step before then, and then we have to add a step at the end. So the first thing is you have to use elimination method to create 2 new equations that remove a variable. So we're going to create 2 new equations and remove a variable. So like maybe get rid of the x, the y, or the z. It doesn't matter. We just got to get rid of one of those. And then we'll have 2 new equations, and it's just 2 equations with 2 variables, so we can solve the system just like we did last week. And then the last thing, we have you should have 2 solutions from up in step 2. So you use those 2 solutions to substitute and find the 3rd variable that we eliminated from step 1. This 3rd variable was eliminated up here. So we substitute the 2 we know to find the one we don't know. So there's 2 new steps here. Now these type of problems, they're going to take a lot of work. This is the stuff in Algebra 2 that's just going to take a lot of space. So I'm going to show you an example, and this is how I set this up. I want you to set this up the same way, and expect this maybe to take half a page. Really a quarter to a half a page per problem, just because there's a lot of work. So put the equation, the set of equations, in the middle of your paper just like I did. Pretend this is paper. And I'm going to prove this. So my first step, step number 1, was to use elimination to create 2 new equations. So I'm going to put the first equation, I'm going to write equation 1, I'm going to put that over here. And I'm going to put equation 2 over here. So what do I want to eliminate? And you have to look at these numbers and see what do I like to eliminate. And I'm looking at the x's and y's and z's. I'm going to say z's because there's all the same coefficient here, all coefficient of 1 or negative 1. So that's going to be easier. So the first thing I'm going to do is pick 2 equations, any 2. And you're going to use those to eliminate z's. I'm going to use the top 2. So what I do is I put arrows from the top 2. And if you need to like multiply them so that they eliminate, you can, but these ones will just eliminate. So I'm going to rewrite these. 2x minus y plus z equals 4. And then I'm going to write x plus 3y minus z equals 11. So what happens when I add those equations up, the z's are going to cancel out. And what I'm going to get is 2 plus 1 is 3x, and negative 1y plus 3 is plus 2y. And z minus z is cancels, equals 4 plus 11 is 15. This is my first equation. Actually, label this one with a 1. Alright, now I've got to create a second equation. I can't use the 2 top equations again. My options are use the 2 bottom or use the top and the bottom. So you have to use a different combo each time. I'm going to choose to use the top and the bottom because one's positive z and one's negative z. I don't need to multiply anything. So I'm going to use the top and the bottom and do it on this side. I'll do it in purple as well, just to keep consistent. Top and the bottom. So top and the bottom. And rewriting those equations, 2x minus y plus z equals 4. And I'm going to do 4x plus y minus z equals 14. And if I just add these, they're going to cancel out. So if I add those up, I get 2x plus 4x is 6x. Y, oh boy, minus y is actually just cancels as well. And z minus z is going to cancel. And 14 plus 4 is 18. Okay, I didn't like this example first, but we're going to keep going with this because I'll do other ones in the future. The nice thing here, the y's canceled out. So what happens is you can just solve for x right here. So divide both sides by 6. And look at this. Your x equals 3. So I already got one of my x's. Now the nice thing, you got to figure out y. Well, what do you plug into? I can plug into one of these originals, but I don't know z. So I'll just have y and z. But wait, we got this equation over here on the left. I'm going to take this left equation. I'm going to rewrite it over here in the middle. So 3x plus 2y equals 15. I know x is 3, so I can plug in to find y. So I'm going to rewrite that equation with a 3 times something plus 2y equals 15. What's that something going to be? It's the 3. So now let's solve for y. You're going to get 6 plus 2y equals 15. Subtract 6 on both sides. Oh, not 6. It's going to be 3 times 3 is 9. That's one of the problems here. One little mistake would really mess me up. So then I'm going to subtract 9 on both sides. And what I'll get is 2y equals 6. Then you divide by 2. And I'm going to get y equals 3. So there's x equals 3, y equals 3. Now I have to solve for z. Well, go to one of these originals, and we're going to solve for z. Any one of these you want to, it doesn't matter. I'm going to take the top one, because I just chose the top one. So 2x minus y plus z equals 4. I'm going to plug in x is 3, so it's going to be 2 times something minus something for y plus z equals 4. I'll put this little tick in z so it doesn't look like a 2. What am I plugging in? Well, I'm going to plug in a 3 for the x. And what am I plugging in? A 3 for the y. So then what I get is 2 times 3 is 6 minus 3 plus z equals 4. And that's going to be 3 plus z equals 4. Subtract 3 on both sides. I'm going to get z equals 1. Z equals 1, x equals 3, y equals 3. So my final answer, ordered pair, is 3 for the x, 3 for the y, and 1 for the z. And that actually matches up to the answer I said. So that's how you get that. Now, we got lucky over here with this example. I didn't think we were going to, but we'll do a few more and I'll show you what's going on. So before I do more, keys to success here. You want to figure out what's easiest to eliminate, and I think the best way is through practice. Sometimes you see what recognize like they're opposites, they add up without multiplying. Sometimes you recognize that you only need to multiply one equation. Sometimes you recognize you can multiply both. You just got to be good at identifying what you want to eliminate, and that just takes practice. Leave lots of room. These problems aren't going to be something you cram into a corner of a page. I expect to see about a quarter of a page of work. And you just saw what I did for that last problem, and that was an easy one. So also take your time, because one little mistake messes the whole thing up. And also, sometimes you can substitute instead of eliminate, and that might help you solve things faster. If you recognize when you can, please do it. So let's try some example. Pause the video if you want to try. Alright, I'm going to solve this. So first step was to create two new equations. What do I want to eliminate? I'm going to eliminate the y's this time because they're all the same coefficient and some are positive and negative. So I'm going to use the top two first. So x minus y plus z equals negative 1, and x plus y plus 3z equals negative 3. Well, when you add those up, what happens? The x's combine to 2x. The y's canceled out. Z plus 3z is 4z. So it'll be plus 4z. Equals negative 1 plus negative 3 is negative 4. So that's one equation. Now I got to draw the second equation. I can't use the top two again, since I'm going to use actually the bottom two, because one's positive and negative. So it's going to be x plus y plus 3z equals negative 3. and 2x minus y plus 2z equals 0. So if you add those up, x plus 2x is 3x, the y's cancel, and 3 plus 2 is 5z equals 3 minus 0 is negative 3. So I got two equations, and this is what I want to do with the first example. I wanted to rewrite both equations below the middle. So I'm going to do the first, I'm going to go 2x plus 4z equals negative 4, and rewrite this equation as well, and go 3x plus 5z equals negative 3. Now, this is a system of equations I want to solve, but it doesn't solve really nice. And you did these last week. Well, you can't just add, and nothing 2 doesn't go into 3, 4 doesn't 5, so I have to choose to eliminate something. I'm going to choose to eliminate the x's because they're smaller numbers. So I'm going to have to multiply the top one by the coefficient at the bottom of the 3, and the bottom one by the coefficient on the top 2, but I got to make one of these negative, so make the bottom negative 2. When I multiply these equations, I'm using an arrow. 3 times 2x is 6x, 3 times 4z is plus 12z, and 3 times negative 4 is negative 12. For the bottom equation, it's going to become negative 6x, negative 2 times 5 is minus 10z, negative 2 times 3 is going to be positive 6. So when you add those up, you will get cancel on the 6x, 12 minus 10 is going to be 2z, equals negative 6, divide by 2, and you got your z equals negative 3. So that's the first one. So now that I got a z, well, I got to figure out an x. So guess what? You just plug it in. So either equation to figure out your x, I'll choose the top one. I'm going to write the top one over here with an arrow. So it's going to be 2 times x plus 4 times z equals negative 4. For z, I'm going to plug in this negative 3. And let's solve for x. So you get 2x minus 12 equals negative 4. Add 12 to both sides. And what you're going to get is 2x equals positive 10. Divide by 2, and I get my x equals 5. Okay, x equals 5, z equals negative 3. Go back to that last step, and it says substitute the two variables to find the third. So I'm going to find the third. Just do one of these original equations. It doesn't matter which one. I'm going to do the top one. You can choose any equation you want, though. So it'll be x minus y plus z equals negative 1. And I'm going to plug in values. So for x, I'm going to plug in 5, because it's 5 for x. And for y, I'm going to go minus y. And then z, I'm going to plug in negative 3. So negative 3 equals negative 1. Let's solve that equation. So 5 minus 3 is going to be positive 2 minus y equals negative 1. Subtract 2 on both sides. So you get negative y equals negative 3. Divide by negative 1, and I get y equals 3. So my final answers are right here. Let's write that as an ordered pair. So the final answer is x first, so 5, y next, 3, negative 3. And that's my answer. Okay, one more. Pause the video. Okay, do another example again. What do I want to eliminate here? There's choices. I'm going to choose to eliminate the x's here because some of these are negatives. You can choose to eliminate y's or z's, doesn't matter. So let's do the first on the left. Well, this is going to be weird. I'm going to just do the top two. So x plus y plus 2z equals, actually, before I do that. No, let's do it this way. X plus y plus 2z equals 3. And then 2x plus y plus 3z equals 7. Okay, I want to eliminate the x's, so I got to multiply the top equation by a negative 2. So then the top equation becomes negative 2x, arrow say we're going down, minus 2y minus 4z equals negative 6. If you add up these equations, cancel on the x's, negative y minus z equals positive 1. So that's the first equation. The bottom, let's just choose the bottom two. Why not? So 2x plus y plus 3z equals 7, and negative x minus 2y plus z equals 10. Okay, they don't add up to eliminate the x's, so I got to multiply. I got to multiply the bottom by positive 2. So if I multiply the bottom by positive 2, the new equation I get is negative 2x minus 4y plus 2z equals 20. And I'm going to drop down the top equation again. 2x plus y plus 3z equals 7 equals, that messed up, equals 7. Now, I'm going to add these. The x's cancel. Negative 4y plus 1y is minus 3y. 2z plus 3z is 5z. And 20 plus 7 equals 27. So those are my two equations. Let's write them again in the middle. I'm going to use purple. So negative y minus z equals 1. And this one's going to go here. Negative 3y plus 5z equals 27. Solving this system here. So, what do I want to cancel out? I have choices. I'm going to choose to cancel out the z's because they're already opposites. You could have chose to cancel out the y's. It doesn't matter. So I'm going to multiply this by positive 5. So this new equation becomes, let's do this in purple, negative 5y minus 5z equals 5. And we just add these two equations up. So I get negative 8y, cancel on the z's, equals 32. Solve for y, divide by negative 8 on both sides, and I get y equals negative 4. Sweet, there's the first one. So let's solve for z. I think this top equation, since it's the smallest, it's probably the easiest. So I'm going to do this one over here. I'll do this in pink this time. Doing this one over here. And it's going to be negative y, so negative something minus z equals 1. That something is going to be the negative 4 I plug in. And negative 4 is positive 4 minus z equals 1. Subtract 4 on each side. I get negative z equals negative 3. Divide by negative 1, and z equals positive 3. So that's the second variable. Now I got to solve for x. I will plug in, let's choose the top equation. Why not? So it's going to be x plus y plus 2z equals 3. I'm going to substitute for x, or for y and z. So x plus something plus 2 times something equals 3. Those somethings are going to be negative 4 for y and positive 3 for z. So when we solve this, it's going to be x minus 4 plus 6 equals 3. Minus 4 plus 6 will be x plus 2 equals 3. Subtract 2 on each side, and my x equals 1. So those are my three answers. I write that as the ordered pair 1, negative 4, 3. That's a lot of work, but it came out to a nice answer. That's it.